Come to my presentation. In this presentation, we shall try to solve system of linear equations using matrix methods, and I'm going to present it in two parts. This is part 1 of that example 4. So in this example, let us take a system of linear equations in 3 variables, and the example here is as follows: x minus 2y plus 3z is equal to -7, then 2x minus y minus z is equal to 7, and then -x plus 3y plus 2z is equal to -8. This is equation number 1, this is equation number 2, and this is equation number 3. So we want to write the augmented matrix for this system of linear equations, and the augmented matrix, if we were to write them down in these different steps. Step number 1. So we take the coefficient of x, coefficient of y, and coefficient of z in x, y in equations 1, 2, and 3, and write the augmented matrix. So that is going to be like this: 1, -2, 3, -7, 2, -1, -1, 7, and then -1, 3, +2, and -8. So this is our augmented matrix. This is the augmented matrix, and our goal is to be able to achieve, I'll write that as step 2. Our goal is to able to achieve this matrix in this row echelon process: 1, A, B, C, 0, 1, D, E, 0, 0, 1, F. What we want in here is we want to have ones along the diagonal and zeros below the diagonal, and if we can achieve that, we have got the solution. We have arrived at the solution, and the solution would be in the augmented matrix format. Then we can read out the value of z, then we can go back substitute and find the value of y, and then go back and then back substitute and find the value of x. So let's get this process started. So in this next step, we're going to use the row operations, step 3, to achieve what we want in this process. Okay, so in here, in this process here, we want a 0 in this location. We want a 0 in that location. So how do we get that? We're going to write it out in this manner: 1, -2, 3, -7, and then the new R2 is going to be equal to 2R1, -2R1 plus R2. So the way we can write that out is as follows: -2 times 1 plus 2, that is equal to 0. Then -2 times -2 minus 1, which was +4 plus -1 is going to be equal to 3, and then -2 times 3 minus 1, so -6 plus -1 is going to be equal to -7, and then -2 times -7 plus 7, which is +14 plus 7, will be equal to 21. And the third row is we'll write it out the same. We did not change anything. -1, 3, 2, and -8. So this is what we have, and if we were to write it out in a clean manner, this is going to be 1, -2, 3, -7, 0, 3, 2, this is, I'm writing more than one rows in here, that's not right. And then the second row is 0, 3, -7, 21, and the third row is -1, 3, 2, and -8. So this is what we have. And if I were to draw a partition line here, and if I were to draw a line along the diagonals, we have a 1 in the first part of the diagonal, but we still have to work on it. We got a 0 there. We want a 0 in this location. We want a 0 in that location. So how do we do that? We're going to perform this row operation one more time and then be able to arrive at that. So let us continue this row operations. So we have 1, -2, 3, -7. Then we have 0, 3, -7, 21, and then the new R3 is going to be equal to R1 plus R3. If we add R1 plus R3, we can make that location as equal to 0. So 1 minus 1 will be 0. -2 plus 3 will be 1. 3 plus 2, that will be equal to 5. -7 minus 8 is going to be equal to -15. Okay, so therefore, if we were to write it out in a clean manner, this we have 1, -2, 3, -7, 0, 3, -7, 21, and then 0, 1, 5, and -15. So this is what we got. And then if we were to draw a line along the diagonal, we still have work to do. We got a 0 there, we got a 0 there. We want a 0 in this location as well. And to achieve that, we're going to perform the row operation one more time and then see what we get. So we have 1, -2, 3, -7, 0, 3, -7, 21, and then we want the new R3. The new R3 is going to be equal to minus the way we can do that is the new R3 is going to be equal to R1 plus 2R3. R1 plus 2R3. R1 is, we can think about it in another way. So let me rewrite this one here. Let me rewrite this row operation a little differently here. We can do this. The new R3 is going to be R2 minus 3R3. R2 is 0 minus 3 times 0 is still equal to 0, and then 3 minus 3 times 1 is equal to 0, and then -7 minus 3 times 5, so that is -7 minus 15, which is minus 22, and then here we have -7 minus 3 times 21. So that is going to be -7 minus 62. That is going to be negative 69. So this is what we got, and if I were to write it in a clean manner, this is going to be 1 minus 2 3 minus 7, and then 0 3 negative 7 21, and then we have 0 0 negative 22 and minus 69, like that. And then if I were to draw a partition line here, and if I were to draw a line across this diagonal here, we want to be able to get a 1 in this location here. We want a 1 in this location here. Therefore, we will now continue in part 2 of this presentation. Okay? So we will complete this problem in part 2 of this presentation.